Please start.
Good evening, everyone. Welcome to the Centenary Celebration of Department of Mechanical Engineering, IIEST Shibpur. Today, we are here for the 25th lecture under the Centenary Lecture series, which is to be delivered by our honorable guest, Professor Pankaj Mallick, on the topic Automobiles, Environment and Lightweighting. This session will be chaired by Professor Vishwanath Doloi, who is Professor in Department of Production Engineering at Jadavpur University. Over to you, sir.
Okay. Good day to all of you. For us, good evening, and for some guests, good morning to all of you. I welcome all to this 25th lecture of Centenary Lecture series. Today, as a former student of Mechanical Engineering Department of BE College, I feel very proud to introduce Professor Pankaj Mallick, our beloved, very senior, I can call Dada of our department. Now he is Professor of University of Michigan, Dearborn, USA. So we want to listen the story of earlier days of BE College and also his journey from BE College to Illinois Institute of Technology, USA, and also about the subject topic automobile, environment and lightweighting. He will share a lot of research and teaching experience on material design, manufacturing for lightweight and sustainable automobile vehicles. At this stage, he is very much energetic and enthusiastic to deliver centenary lecture in this current topic. So we are very eager to listen his lecture. Professor Mallick, he is now professor in the Department of Mechanical Engineering at University of Michigan, USA. He joined the university in 1979 and was the director of interdisciplinary program in the College of Engineering and Computer Science from 1997 to 2019, almost 22 years. Professor Mallick obtained his bachelor's degree in mechanical engineering from BE College. It was under Calcutta University in 1966. Subsequently, he received his MS in 1960 and PhD in 1973, both in mechanical engineering from Illinois Institute of Technology, USA. It is very famous institute in the world. Professor Mallick's research is in the area of mechanical properties, design, joining and manufacturing of polymer matrix composite, lightweight automobile materials. He has published several journal and conference articles in this area and contributed several book chapters, and also he has authored 2 textbooks on composite material, that is Composite Engineering Handbook and Lightweight Automobile Material Design and Manufacturing for Lightweight Vehicles. So Professor Mallick received the Distinguished Faculty Research Award in 1997, William E. Tarton Professorship Award in 2007, and Ogden G. Arden Interdisciplinary Teaching and Research Award in 2014, and he is a life member of ASME and fellow of American Society for Composites, and he is renowned professional engineer in the state of Michigan, USA. So I am very much proud to introduce Professor Mallick, our senior Dada of BE College. So now I request Professor Mallick to deliver his lecture. So, thank you. Professor Mallick.
Thank you. Yeah, thank you very much for inviting me for this occasion here. Thanks to all of you for joining the presentation today. I graduated in 1966, as Professor Doloi has just mentioned. Can you hear me well? Is it okay?
Yes, yes.
Okay. So I graduated in 1966, and it's hard to believe it's 56 years ago that um, I was at the B College, which is now IIEST. I have visited IIEST several times since then, and I remember Professor Karmakar sitting in his office and talking to him about a number of things when I visited there, and made a presentation as well to the students at that time. So my work has been in the automotive materials area. I am at the, I would say, a crossroads between mechanical engineering, materials engineering, and mechanics of materials, or um, strength of materials. My experience has been in the automotive industry. Before I joined the university, I worked for Ford Motor Company for a number of years, which is not in my bio, but I was there for a number of years. And I have had many research um, contracts from the automotive companies as well as other organizations such as the Department of Energy and the National Science Foundation. What I decided to talk about today is, I think, in my opinion, is very important for all of us, and that is the environment, and what's the relationship between automobiles and the environment, and also how we can um, uh, mitigate the problem that we have with the environment. And that's the topic that I have selected. With that, let me go to the first slide, if you don't mind. Can you project the first slide, please? I was able to see it before. Now I can see it.
Yeah, Dr. Das, I think.
Yeah, so that is the topic: automobiles, environment, and lightweighting. Can you go to the next slide, please? So the outline of my talk, I'll first talk about the value of automobiles. Then I'll talk about automobiles and the environment. Then I'll look into automotive design challenges to circumvent the problem that automobiles create in terms of damaging the environment. And then I'll talk about lightweighting, which is the topic of most of my research. And then I'll have a concluding slide. Please, next slide, please. So, value of automobiles. Let's go to the next slide. We take cars for granted, automobiles for granted. It is an essential element of daily life in most countries in the world. We cannot think life without automobiles today, because cars provide mobility to move, travel, go anywhere, freedom to live anywhere, flexibility to travel anytime, livelihood for many people, status, prestige for many, for those who actually own very high end cars. And also, it is part of the Western culture, nostalgia, and so forth. So it is a valuable product. It's not only a product, it is actually part of our life almost for all of us, more or less. Can you go to the next slide, please? So first, let's look into the social benefits. It provides employment. It is essential for commercial transportation, for transporting goods from one part of the country to the other part. It's a source of economic power for countries who have large automotive industries. It provides tax revenues for the governments. And it is also important for highway construction repair money. In fact, in the United States, the rise of the automobiles in the early 20th century created the highways, network of highways that was not seen before in anywhere in the world. And it's still, I would say, in my estimation, one of the best highway networks in the world. Technological advancements through new innovations is occurring almost every day. Today's cars are so different from the cars that were produced in the early 20th century. Of course, that's because of the advancements that took place in technologies. through new innovations, not only in mechanical products, but also electrical products, electromechanical products. Now we are talking about information technology. All of these are being blended into automobiles today. And finally, of course, it provides entertainment. Think of motorsports that take place all around the world. People get excited about these sporting events. So it also provides entertainment. Next slide, please. This is the history of automobile sales over the last several decades. I am going to talk mostly about my experience in this country. But you can see that I have listed here from 1978 through 2020, the number of vehicles that have been produced in this country, the total fleet that is available. There are ups and downs, but you can see there's more or less between 9 million vehicles per year to about 16, 17 million vehicles. And then it's divided into passenger cars and light trucks. Under light trucks would come the pickups and other light vehicles. Passenger cars and light trucks together will make the light vehicles. But in this country, in 2020, 14 million vehicles were produced. I was looking into China. China is producing about 25 million vehicles. In recent years, they have been much more productive in making automobiles than the United States. And Chinese vehicles are, of course, mostly sold in China, whereas the US has vehicles coming from many parts of the world. Let's go to the next slide, please. Here I want to take you through some economic values of the automotive industry. In 2018, motor vehicles and parts accounted for $518.1 billion out of $18.6 trillion of US GDP, which is almost 2.8% share. I was looking up the 2021 statistics, it's about 3% of the share. So it's a large share of US GDP. I'm sure it'll be similar in many other countries as well. Automotive industry in this country employs over 1.7 million people and pays over $500 billion in annual compensation. So it's a huge it has a huge economic value. Let's go to the next slide, please. Some other important statistics that I put together here. Nearly 12 million cars were manufactured in the US in 2018 and 8.8 million cars in 2020. Worldwide, 95 new cars are manufactured every minute. Can you imagine that? And of course, that is worldwide, including China and Japan and Korea, India, Australia, other parts of the world as well. And if you line up 1 day of production, it will be 400 miles long. So imagine the impact of automobiles we have on our lives. Can you go to the next slide, please? Okay, so I've talked about the good things. Let's talk about some of the bad things that automobiles do to us. Negative side of automobiles. Obviously, it creates air pollution and health problems. It is connected to global warming through the greenhouse gas emissions. It causes accidents, injuries, and death. I remember when I came to this country in the late 1960s, yes, 1967, I came to this country here. Around that time, there are about 20,000 to 30,000 people who are killed every year in automotive accidents. Now it's less, but it's still quite a large number. It causes road congestion, noise pollution, urban sprawl, which means that people, instead of living in the city, move away from the city, live in suburbs, and travel to to their employment places in the cities. So, and that's actually a big problem in this country right now, because the cities are dying, whereas the suburbs are growing. And of course, for people to go from suburbs to the cities, they have to build highways. They have to be maintained. So the cost of doing all of this is tremendous. Also, depletion of natural resources, because we use petroleum, that is, of course, a natural resource, or natural gas, that's also a natural resource. So depletion of natural resources. And we may not have petroleum and natural gas forever. In a couple of 100 years, although we may not be alive, we obviously will not be alive, but we will not see this, but our children and grandchildren and their children will suffer if we run out of natural resources. Next slide, please. So air pollution, health problems, and greenhouse gas emission. These are three things that are very negative sides of an automobile, caused by three kinds of emissions. One kind, of course, that would be coming out of our tailpipes, the automobile's tailpipes, and they are hydrocarbons, different nitrogen oxides, carbon monoxides, carbon dioxide, particulates if diesels are used, evaporative emissions, and refueling emissions. Those are mainly hydrocarbons. Can you go to the next slide, please? So hydrocarbons cause greenhouse gas effect. They also cause smog. They react with nitrogen oxides to produce ozone. They cause eye irritation, lung damage, cause respiratory problems, potentially also carcinogenic. In fact, one of the reasons many medical experts believe that children are getting more asthma today is because of all of these pollutions that are created not only by automobiles but other products that we use. So it is highly irritating from the standpoint of with moisture to create acid rain. It's also a cause for smog. Carbon monoxide, long exposure can cause death. Carbon dioxide obviously has a large greenhouse effect, but in fact, hydrocarbons have a larger effect than carbon dioxide itself, because hydrocarbons stay in the environment for a longer period of time, and so they have a higher greenhouse effect than carbon dioxide. And then particulates and soot that come out of diesel engines, they cause also respiratory disease and maybe carcinogenic. Let's go to the next slide, please. Other problems, when you go to fill out gas tanks, we actually emit hydrocarbons from gasoline vapor evaporation. Although you can think that that's a small amount, it still can add up to cause big problems. Refrigerant causing ozone layer, CFC, that has long been replaced now, but with less harmful refrigerants. But that was one of the main reasons for causing ozone layer several years ago. Also, noise pollution. How can you ignore that? In car, while you are driving a car or sitting in a car, also people who live on the sides of roads, bombarded by the noise created by cars going by, pushing by. Okay, let's go to the next slide, please. So, sources of carbon dioxide for a typical household. I wanted to show this slide because we own cars, we have cars in our garages, and we drive cars. Vehicles in a typical household create 51% of the carbon dioxide out of the 100% that we create in our household. Appliances create 26%. Heating and cooling, 18%, and waste would be 5%. Now, each gallon of gasoline burned creates 20 pounds of carbon dioxide. The average vehicle emits around 6 to 9 tons of carbon dioxide per year. So can you imagine the amount of carbon dioxide that we ourselves create because of the cars that we drive? And that, as this particular slide says, is the largest amount that we create in our own households. Let's go to the next slide, please. This is a pie chart which shows the US greenhouse gas emissions. On the left side, this is 2017. It has improved slightly, but not much. US, out of all the greenhouse gases that were emitted in the United States in 2017, 82% was carbon dioxide. And then if we look at the right side, it's the total US gaseous emissions by economic sector. And here we have transportation sector, electricity sector, industry, commercial and residential sector, and agriculture sector. Look at the transportation sector. It is as high as that of the electricity sector. Electricity sector would be the power plants. They create 28% of the carbon dioxide greenhouse gases, that are emitted in the United States. But transportation is right next to that. In fact, it's slightly higher, 29%. So the transportation here does not only include automobiles, but also airplanes and other vehicles that are used for transportation. Let's go to the next slide, please. And then, again, this is 2017. Numbers are slightly different, maybe, perhaps, but not much. Light-duty vehicles, 59% of the greenhouse gas emissions came from light-duty vehicles. Medium and heavy-duty vehicles, 23%. Aircrafts, rail, boats and ships and others, much smaller amount. What I'm getting at is that automobiles are responsible for creating much of the greenhouse gases that are responsible for global warming. And we're all feeling the brunt of global warming that is occurring. Parts of the world are getting hotter, unlivable. In the United States, for example, you hear about the forest fire. There's more of that every year. In fact, part of California is burning right now. Part of the West is so dry that even if you have a small spark, it can cause a forest fire of unimaginable amount. More hurricanes are occurring, more tornadoes are occurring, and many of these can be attributed to greenhouse gas emissions. And as I'm trying to point out here, is that many of these are because of the vehicles that we drive today. Let's go to the next slide, please. And this is again another statistic that I wanted to show here, carbon dioxide concentration, how it has increased over the years. On the left side, there's a chart which shows 800,000 BCE to 2015 after Christ. And you can see that the carbon dioxide concentration was roughly about 225 to 200 to 250 parts per million. But since 1950, it has gone up to 400 parts per million. And it is increasing. It has an increasing trend. And that is one of the reasons why the global warming is taking place. Let's go to the next slide, please. So some other tale of today's automobiles. Gasoline engines waste more than 2/3 of the fuel it burns for a variety of reasons that I'll show you later. Gasoline engines emit 20 pounds of carbon dioxide for every gallon of fuel burned. Typical vehicle weighs 20 times the weight and has 100 times the space occupied by the person it carries. Imagine that. One person is driving a car that weighs about 3,000 pounds. Does it make any sense? A typical value weighs 20 times the weight and has 100 times the space occupied by the person it carries. Sits idle 95% of the time. You go to the office, use your car, it sits there for the entire day for 8 hours. You drive back home, park it in your garage, sits there all night. In the morning, you drive it again. So 95% of the time, it just sits idle. It guzzles 9 million barrels of oil every day in the United States. So again, showing that there are very bad negative sides for what we all do for our own, I would say, livelihood as well as entertainment. Let's go to the next slide, please. Why fuel economy is important? I don't have to probably show this slide because I have already made my points, but it is clear that it will save money for the vehicle owner. We tend to ignore that, but it can save a lot of money. The gasoline price here is going through the roof. I'm sure it's the same thing in India. I read it on the weather every day that how the price of gasoline has gone up or is going up. It's the same all over the world. But the gasoline that we used to buy here about 2 years ago for, let's say, $3 per, well, less than $3 per gallon is right now about $5 per gallon. And so it will save money if we can make the cars more fuel efficient. It reduces emissions, it reduces oil consumption, and increases also energy sustainability. Let's go to the next slide, please. So again, this is another slide that I wanted to show that if we can reduce the miles per gallon that we drive, we can actually reduce the carbon dioxide that we create. So if our car is it burns 15. I'm sorry. If it has a fuel economy of 15 miles per gallon, it will create 12.2 tons of carbon dioxide per year. But if it is 45 pounds per gallon, we are not there yet. It will create only 4.1 tons of carbon dioxide per year. So fuel economy is very important. Here we're showing 15 to 45 and reduction of carbon dioxide by almost 3 times. So 3 times fuel economy in the vehicles that we design will reduce the carbon dioxide emission by 3 times. Let's go to the next slide, please. So in this country, there is something called CAFE standard. CAFE stands for Corporate Average Fuel Economy, which is a mandatory minimum fuel economy standards for all cars and light trucks manufactured in the United States. These are calculated based on sales-weighted harmonic mean, and it's expressed in miles per gallon of a manufacturer's annual fleet of the current model year passenger cars or light trucks. It was first enacted in 1975, and that was because that was the first time the United States faced the energy crisis. First enacted in 1975 as part of the Energy Policy Conservation Act, or EPCA. CAFE standards went into practice first in 1978. Can you go to the next slide, please? So if the CAFE standard is not met, the manufacturer pays penalty in the form of a fine. And the fine is $5.50 per 0.1 miles per gallon under the CAFE standard, multiplied by the manufacturer's total production in the United States. So the CAFE standard does not mandate each vehicle type that a particular manufacturer produces. It will take the fleet average and then it will fine based on that fleet average. Total fines collected in between 1983 and 2011 was $844 million. It's not a small amount. So the manufacturers in those years have paid a hefty fine because they could not meet the CAFE standard. And that particular fine is still in place. I was checking that only yesterday, and it is still $5.50 per 0.1 miles per gallon of violation. Let's go to the next slide, please. So here are the standards over the years. 18 miles per gallon in 1978. That is when it first came into place. It went up to 27.5 in 1998, in 20 years, 35.5 in 2016, and it is now mandated to be 54.5 miles per gallon in 2025. So we have 3 more years. By then, the car manufacturers will have to make their vehicles fuel efficient enough to have the 54.5 miles per gallon CAFE standard, meeting the CAFE standard of that amount. CAFE standards for light trucks are slightly lower, 25.7 miles per gallon in 2013. I think if you go to the next slide, you'll see how. Can you go to the next slide, please? So this is how the CAFE standards have changed over the years from 1978 to 2016. For a number of years, the standards were not changed, but now it is in the upswing. And as you saw in 2025, it is going to be 54.5 miles per gallon. And then go to the next slide, please, which shows how the CAFE standard has been met by the vehicles. We are looking into 4 different diagrams, curves here. One is the domestic car. The domestic car is the domestic car, meaning the cars that are manufactured in the United States. They are in the blue line. The black line is for the total fleet. The top line is for the imported cars. So the imported cars were doing much better in the early years of CAFE standards. But the domestic cars, the cars produced in the United States, are as good as those that are made that are imported from outside. But right now, I'm looking at 2020. The CAFE's is roughly about 36, 37 miles per gallon, which is quite far from what we have to achieve in another 3 years. So there had been, of course, resistance from the car companies, and there had been also some hesitations from the government to mandate 54.5. In fact, the previous president was not happy about that, but I think it has come back again with the current president. Okay, let's go to the next slide, please. So there are things that we can do, and this is what I'm trying to point out here, we meaning all of us, and there are things that the car companies can do. So first I'm going to look into societal ratchet, the things that we can do, or individually, or society as a whole. Some of these are already being done. Our dependence on motor vehicles are not going to change, but can you reduce the number of journeys we make? In USA, 85% journeys are made by car, but 20% is purely for social and recreational purposes. Can we reduce that? Home officing, some of this is already occurring, not because we are kind enough to think about the environment, but because of COVID. Video conferencing, internet shopping, all of these can contribute to less use of gasoline. Can we use alternative forms of transportation, public transportation? And of course, in India, it is very common to use public transportation, but here it's not that common. It accounts for only about 2% of passenger travel in the United States. Can you imagine that? Only 2%. If you ride in a bus from a suburb to the city, which I've done many times, you will see hardly a few passengers in the buses, because most people have cars, not just 1, 2, or more, and so therefore they're reluctant to go by bus. And there are, of course, also not many buses available in many cities, or public transportation available in many cities. Group travels, carpools, Also, non-automotive transportation by bicycles and walking. Can we use more environment-friendly cars? One-person or two-person cars instead of big family cars. So Nano did not succeed. There are many reasons for why it did not succeed. Tata's Nano, that's what I'm talking about here. But that's a two-person car. And can we use a car like that instead of buying a gas guzzler, which could be, a 6 or 8 passenger vehicle, but only one person is driving and using it most of the time? Use smaller cars instead of gas guzzlers. Use electric or natural gas vehicles. Now, these are the things we can do ourselves. And perhaps there are more things we can do, but I could think of some of these ideas that I have put together on this slide. So we as the citizens of this world will have to think about the environment and our future. And so we should be also thinking about how we can help improve the environment that we live in. Can you go to the next slide, please? But the industry, the automotive industry, has also a big responsibility. And the larger the vehicle, the more profit they make. So the question then I pose is, can you design and promote? That's the thing that I think is more important, promote smaller cars instead of more profiting gas guzzlers, such as SUVs, light trucks, etc. Can you do that? As I said, the bigger the car, the more expensive it is, the more profit is made by the car manufacturers. So they have less of an incentive to make smaller cars. In fact, if you look at then bigger cars such as SUVs and light trucks. Can you design and promote more environment-friendly cars? Design and promote cars that use renewable energy sources such as biofuels and hydrogen fuel cells. Design and promote electric vehicles. Now, some years ago, I would say about 20 years ago, fuel cell vehicles were riding, there are not fuel cell vehicles on the road, but there's a lot of research money was spent on fuel cell vehicles. Now you hardly hear about them. Now the buzz is about the electric vehicles. GM and Ford and many other companies have invested large sums of money in making electric vehicles. Tesla, of course, is famous for it. But we do not have as many electric vehicles today as we hear about them. Of course, the projection is that in another 10 or 20 years, we'll have fewer gasoline-powered vehicles, more electric vehicles on our roads. The question then is, will we be able to support these electric vehicles? And that's something that the U.S. government is pushing. I'm sure other governments are also looking into. I was happy to see that Tata is producing 50,000 electric vehicles. I think they have said that in a public announcement. But the question is, how are the electric vehicles going to be electrified, so to speak, as they're driven on highways or roads? Let's go to the next slide, please. So now I want to go into automotive design challenges a little bit, talk about them. Next slide, please. So challenges to the automotive industry. This is something that I think the automotive industry knows very well, and they're working toward it. Increase fuel economy, reduce greenhouse gas emission and air pollution, and improve life cycle values of automobiles. Now, efforts to meet these challenges, looking into energy alternatives such as electric vehicles, hybrids, fuel cells, etc. Vehicle weight reduction, which I will talk about in a few slides. Improved powertrain design, reduce friction and other losses, improved aerodynamic design, and reduce tire rolling resistance. These are all of the things that need to be done in order to improve fuel economy, make our vehicles more environment friendly. Can you go to the next slide, please? So if you look at where does the energy go when you drive a car, 62.4% are engine losses, excuse me. Standby and idling, 17.2%. Driveline losses, 5.6%. Accessories, 2.2%. Accessories are like air conditioners, for example. Aerodynamic drag, 2.6%. Rolling resistance, 4.2%. Braking, 5.8%. So there's a lot of energy that is lost, which I was pointing out before, and a smaller amount of energy goes into driving our vehicles. So then the emphasis should be really to reduce this energy losses. And that's being done through a variety of design changes that are occurring or has been occurring over the years, particularly for the last 20 years. Let's go to the next slide, please. So I think you already know all of these energy alternatives: ethanol, natural gas, biodiesel, hybrids, onboard battery electric, plug-in battery electric, and hydrogen. I put term, meaning that are they now available? When would they be available? Near term, long term? So ethanol, natural gas, and biodiesel are current, near term. Hybrids are current and near term. Then you have the onboard battery electric, near term, plug-in battery electric, long term, and then hydrogen fuel cells also long term. I'm happy to see that the Honda is actually now producing a commercial vehicle which is powered by hydrogen fuel cells. But more needs to be done there as well. Let's go. Next slide, please. So vehicle design challenges, fuel consumption reduction, I've been talking about that, but safety and survivability is also would also be on top of the list here. People want to have a safe car. And when there are accidents, we want to make sure that the people who are in the vehicle survive the accident. Performance, of course, is very important. Power, people want acceleration. They want to go from 0 to 60 miles per hour in 2 seconds. Comfort is important. Comfort comes from size. NVH stands for noise, vibration, and harshness. Ride quality, functionality, how many things you can do with the car. Entertainment, and integration of information technology. Now, entertainment and integration of information technology are relatively new. We want all kinds of entertainments in our vehicles today, and also information technology are seeping into our vehicles as well. They're important. You cannot drive a vehicle without a GPS these days. What happened to all the maps that we used to carry before? They're not there anymore. The map business has gone out of business now. It's all GPS now. So that's been integrated into our vehicles. Let's go to the next slide, please. So lightweighting is important. And every 10% reduction in vehicle weight can result in 5 to 8% greater fuel efficiency. And reducing vehicle weight by 100 kilograms results in carbon dioxide reduction up to 12.5 grams per kilometers. So lightweighting is one aspect of the design challenges that I pointed out. We want to make the vehicles lighter. That will improve the fuel economy. It will also reduce the carbon dioxide or greenhouse gas emission. Let's go to the next slide, please. Vehicle lightweighting can occur in many different ways. Use structure that would be lighter instead of body on frame. Use body in white or space frame. Use materials with lower density or higher mechanical properties. Reduce the number of components by parts consolidation and/or elimination. Redesign parts to reduce thickness. reduce factors of safety by reducing variability and or uncertainties and improving reliability. This requires more testing and design validation. The current trend is to reduce the testing phase and design validation phase. Everything is done on computers these days. Very little physical testing is done. And in my opinion, that is one of the reasons we still have high factors of safety integrated in our automotive designs. Factors of safety in designing vehicles are in the range of 5 to 8, whereas when you design an aircraft, the factor of safety is less than 2 or around 2. So there's a big difference in the factors of safety in the designs that we do for our automobiles and for our aircrafts. And also consider secondary weight-saving possibilities, for example, using smaller engines and so forth. Let's go to the next slide, please. So, role of advanced materials in vehicle design, they will reduce vehicle weight. They will provide required, when you are actually looking for advanced materials in vehicle design, you have to think of all this. That's what I am going to say. Reduce vehicle weight, provide required performance, safety, and comfort. Reduce energy consumption in production and manufacturing. Reduce resource depletion, and also reduce effects of environmental emissions. Let's go to the next slide, please. So these are the different materials that we use in our vehicles, and their different percentages are in there. I don't know how much time I have, but I don't want to go into the tables into too much details, but steel is still the largest amount of material that we use. 55% of the vehicles today is made out of steel. There are aluminum alloys and polymers or polymer matrix composites that are used more and more, but we still have vehicles made out of mostly steels. Let's go to the next slide. So here are the lightweighting materials. Yes, there are steels, but steels are different today, particularly for automotive steels are different today than they used to be 20 years ago. 20 years ago, we are using low carbon steels mostly, but now we have advanced high strength steels. We also have something called third generation steels. So the steel companies are evolving into making better steels, better meaning that not just in quality, but also in mechanical properties. The problem is you cannot change the density. The density of steel is still 7.8, as you'll see in a slide or two. But you can improve the strength of the material, and that's where the research on steels is heading. We are using more aluminum alloys. In fact, there are also talks about using magnesium alloys, and of course composites, carbon fiber reinforced polymers, glass fiber reinforced polymers, also natural fiber reinforced polymers. Here we're looking into natural fibers made out of coir fiber, jute fiber, hemp, flax fibers, things like that. Now they're not going to be making the entire vehicle, but there are places where you can put natural fiber reinforced polymers, which would give you lower weight. Can you go to the next slide, please? So here's the comparison that I quickly wanted to make. DQ steel is the standard low carbon steel. Look at the density, 7.87 grams per centimeter cube, which is the second column on this particular table. The modulus is 207 gigapascal. Yield strength is 186. Tensile strength is 317. Elongation is 40. That's the ductility. Look at the DP steel. DP stands for dual phase steel, which is one of the advanced high strength steels. Look at the yield strength of the material and the tensile strength, much higher than the low carbon steels. Then look into something called boron steel. Boron steel has a yield strength of 1100 megapascal and 1500 megapascal as the yield strength. So steel companies are producing these high strength steels. The higher the strength, the lower would be the thickness that you require to design a part. while the strengths are increasing, the density and modulus do not change. If you go to aluminum 6061 T6, it has a density of 2.7, and that's why there is so much interest in replacing steel with aluminum. Modulus is also much lower, and strengths are also lower. But the good thing about this is that the modulus to density ratio of aluminum is the same as the modulus to density ratio of steels. So the interest in replacing steels with aluminum comes from the fact that it has a much lower modulus, yet it has the same modulus, much lower density, yet it has the same densities to, the modulus to strength, modulus to density ratio. Then if you go to carbon fibers and glass fibers, all of these, you look at the density values. We're talking about 1.54 compared to 7.87. This is the second column of this chart. And then look into some of the strength properties that we have. Now, they have to be designed properly. It is not an easy task to design a composite for an automotive component, particularly if it has complex design. And it has been traditionally used in steels, but it can be done. There are many examples of where it is being done, and I'll show you a few of them a little later. But composites can actually bring a much larger weight saving and therefore can increase fuel economy. Okay, let's go to the next slide, please. So quickly, these are some of the advantages of steels. We've got high modulus, highly recyclable. That's an important aspect of material selection today. Can it be recycled? Very low cost compared to the other materials. But disadvantage is 7.87 high density grams per centimeter cube. Let's go to the next slide, please. So as I mentioned, the steel companies are making better, higher strength steels. But this higher the tensile strength, lower is the elongation. This is sometimes called a banana chart because the chart looks like a banana, but it divides the steels in different segments. So the low carbon steels would be on the left side of this diagram, and the very high strength steels are on the right side. The higher the strength, the lower is the elongation, and therefore the lower is the formability. It becomes much more difficult to produce the shapes with very high strength steels. So therefore, the steel companies have invested a lot of research money into developing steels that will have both high strength and high elongation compared to low carbon steels. That's where the third generation steels are coming in. It's in the space between the green areas on the top right corner and the banana area that I pointed out on the bottom. So third generation steel would be in the middle there. Let's go to the next slide, please. Here are some of the applications, and the high strength steels are being used in areas where we need more crash worthiness. They actually provide more safety and survivability for the passengers and the drivers. So they are in the front ends, on the back ends, also in the roof or on the sides, mostly in the frames. Let's go to the next slide, please. You will see the same thing here. The A pillars and the B pillars and so forth, these are required for high crash resistance, crash worthiness. That's where the high strength steels are used. The boron steels that I was talking about before with 1500 megapascal strength values would be on the B roof bowl or on the B pillar of this particular vehicle. Let's go to the next slide, please. Now, going to the aluminum alloys, I already pointed out low density, but there are many disadvantages: low modulus and steels, lower formability. But we are using more of it because it can give us a weight advantage. Let's go to the next slide, please. So here are some of the examples of where aluminum alloys are being used. You can see that you have aluminum powertrain castings. You also have aluminum outer body panels. So aluminum is not going to go into the structure of the vehicle. It is going to go into the panels. So body panels are going to be made out of aluminums because aluminum doesn't have enough strength to make the vehicle more crash worthy compared to steels. So while steels are going to be in the cage, that's what they're called, the cage meaning the frame of the vehicle, aluminum panels are going to be on the outside of the vehicle. So here you see some of those. You have the aluminum body panels, you have the aluminum closure panels, the aluminum extrusions, and so forth. Let's go to the next slide, please. And here is another example of where aluminum is being, this was done in 1994 by Audi in first aluminum space frame structure, aluminum extrusions in the space frame, and aluminum body panels. But aluminums are not easily joined by spot welding. So they had to come up with a technique called self-piercing riveting. So a lot of the structure here is made out of that. But they achieved 40% weight saving compared to a vehicle made out of steel of the same size and quality. Let's go to the next slide, please. And here's some more examples of use of aluminum. Let's go to the next slide, please. And this is a remarkable application of aluminum in automobiles. In 2015, Ford came up with this pickup truck F-150, which is their most popular vehicle even today. They make more money out of F-150 pickup truck compared to any other vehicles that they make. But it is made out of 6000 series aluminum alloy body panels. All of the body panels here are made out of 6000 series aluminum. And joining is done by self-piercing rivets and with or without adhesives. And look at the weight reduction they achieved by doing that. Compared to steel, they achieved 700-pound weight reduction in this vehicle. So this was the first time you see such a wide application of aluminum in our vehicles. Let's go to the next slide, please. There are many challenges, as you can see here. Formability is a problem, joining is a problem. So all of these are addressed by more research and development, not only in the car companies themselves, but also the suppliers. Aluminum suppliers are involved in many of these research that's required for improving the application of aluminum alloys. Let's go to the next slide, please. And then the next one is magnesium. Low density, you can see 1.74 compared to steel 7.87. Many disadvantages, of course, comparatively low modulus, only 45 gigapascal compared to 207 for steel. But because there is this low density advantage, magnesium has been touted anyway for many of the applications in automobiles. It really hasn't caught up much, but it is still a possibility of seeing magnesium in the instrument panel or in the front end of the vehicle. Let's go to the next slide, please. Here are some examples of magnesium alloys: engine block, front cross member made out of magnesium. Let's go to the next slide, please. Then the polymer matrix composites. The biggest advantage would be the low density, but more important than that would be the very high strength to density ratio and high modulus to density ratio. You can achieve remarkable weight saving using polymer matrix composites, but there are many problems. One of them being the high cost. And this is where the car companies are very sensitive. They do not want to use too much of carbon fibers today. That's where the weight reduction would come in because of carbon fibers' high cost. Let's go to the next slide, please. So here you're looking at various applications that are being thought of or being used: body panels, body structural components, frame and subframe sections, chassis components, body and white structure. And you'll see some examples in the next slide. Next slide, please. CFRP has a higher weight saving potential than GFRP. CFRP stands for carbon fiber composites, GFRP for glass fibers, but they're high priced. And so car companies shy away from using carbon fibers. This is one of the reasons, not the only reason, but this is one of the reasons why carbon fibers are not used in motor vehicles today by using we don't use much of it today. But if you think of it, 787, Boeing 787, the entire fuselage is made out of carbon fibers, carbon fiber composites. If you go to the other aircrafts made by Boeing, you will see more and more carbon fibers are being used in those aircrafts, but not in the automotive industry. But there is a great possibility of doing that in the near future, particularly when you have to meet a very high CAFE standard. Let's go to the next slide, please. Here are some examples of various, this is 2004 model year. Even at that time, some of the high-end vehicles were using carbon fiber composites. Let's go to the next slide, please. BMW is one of the pioneers in using carbon fibers. This is BMW M6 roof panel. The black panel that you see on the roof, that's all made out of carbon fibers. And so BMW is using more and more carbon fibers in their vehicles. Of course, it's a high-end vehicle, meaning that it is an expensive vehicle. And they don't make too many of those as many of the other vehicles that I mentioned before. F-150 are made in thousands, whereas these are 100,000s or more. These are only in thousands. Let's go to the next slide, please. Some more of these. Here is a strut made out of carbon fibers. The seat structure is made out of carbon fibers. Next slide. The front crush members in SLR McLaren, you see that is made out of carbon fibers. So you will see more carbon fibers coming in our vehicles in the next 10 to 15 years. At least that's what the projection is. Let's go to the next slide, please. And here's another one, front crash box made by Audi in 2014, and how the crash box will crush when it is impacted on the right side. Let's go to the next slide, please. And here I wanted to point out that, yeah, all of the materials that I talked about have good attributes and bad sides. And so the thinking is now that we're not going to make a car out of carbon fibers only, or we're not going to make a car made out of steels only. What we need to do is to look into how we can use various materials according to their advantages. Where can we put them to their best ability? So here we are looking into an example where this is called Mach 2, MMLV standing for multi-material lightweight vehicle. But here, if you look at the vehicle structure here, the aluminum sheets are used in these two aluminum, the front ends. The yellow part is magnesium. The red part is the boron steel. That's the B pillar. The roof panel is made out of carbon fibers, and there are many aluminum castings in this vehicle. So this is called multi-material lightweight vehicle. And look at the weight saving that was achieved by using these multi-materials in the right places. And that's 50% weight reduction. That's remarkable. It's not in the market. This was a demonstration piece that was made. But we need to actually think about more of this lightweighting, which would give us not only fuel economy improvement, but also greenhouse gas emission reduction. Let's go to the next slide, please. So in conclusions, automobiles are not going to disappear. However, future automobiles will be much different from what we drive now. As a society, we must do everything individually as well as collectively to reduce greenhouse gas emission and conserve resources. Lightweighting is one option. Other options are alternative power source, electric vehicles I mentioned, improved vehicle design, adopting good driving practice, and also reducing travel demand. With that, I'll conclude. And if you have any questions, I'll be happy to answer. And thank you very much. I went a little too fast because I lost a little time in the beginning. I'm sorry about that, but I took probably about more than an hour, I think, to present my slides.
Thank you, Professor Mallick, for your nice presentation and thoughtful presentation. So you have discussed about various aspects of lightweight vehicles, starting from the value of the automobile and different societal benefits and environmental versus automobiles, and also you have mentioned various emissions aspect, greenhouse gas emissions, and finally you have mentioned about the lightweight vehicles. But you have explained about the CAFE, what will be the range of CAFE by 2025, 4.5 miles. But in India, I think there is no such CAFE standard where the fine government can actually penalize the manufacturer. So I think to maintain that CAFE or Indian standard, that type of fine or penalty is required, so that we can get the high fuel economy car. And lastly, you have mentioned about that lightweight vehicle, how to reduce the weight of the vehicle, and it should be multifunctional material, and you have mentioned about the right material at the right place for right purpose, so that the low cost and sustainable economical lightweight vehicles can be manufactured. So thank you very much, Professor Mallick, for your nice presentation. Now it is open for discussion, as well as anybody can ask questions or give suggestions. Okay.
May I put one question?
Yes.
I am Professor Shantanu Das from Kullani Government Engineering College, not that Shantanu Das from IIEST. That is one problem. No, I think magnesium was projected also for a lightweight material, but sometimes people are saying that magnesium can also ignite at certain temperature, etc. So, any comment from the speakers, please?
So this question is asked many times by many people at many locations, wherever magnesium is discussed. If you remember in high schools or in college, when you in a chemistry class, when you use pure magnesium, it ignites very easily. But magnesium alloys do not ignite as easily. That's one of the things. And so one of the magnesium should not be machined, first of all. Let's put it this way. Even if it's machined, proper care should be taken so that the temperature during machining doesn't become too high and magnesium will ignite. The question is, if magnesium is used in very large quantities in our vehicles, and if there's an accident, will there be any problem? The magnesium companies and the association would say no, because it is not pure magnesium. It will be magnesium alloys. There's a large amount of zinc in there or other aluminum in there. So overall, the magnesium alloys that are being considered are more safe compared to pure magnesium.
May I ask a question, please? May I ask a question, please?
Please go ahead. Yeah, please go ahead.
Hello.
Yes,
Yeah.
go ahead, please.
Yes. My name is Palit. I am from Mechanical Engineering 67 batch. That way, you are my 1 year senior, and it could be that we have crossed our path while we were in the college.
Probably did, yes.
Uh, Thank you very much for this very informative talk in which huge amount of informative data has been furnished. I have just one question, if you can throw a little more light on it. So in the new design, when you are going for, say, these aluminum alloys or various types of plastics and composites, so one important thing takes place, that is reducing part count. In
Right.
fact, there is a huge amount of reduction in part count with these two methods. And part count reduction also means the energy you and the efficiency, of course, what you have for manufacturing and assembling the vehicles, that also comes down quite a lot. So that
Absolutely,
also
yes.
must be giving some benefit in terms of the environmental concerns.
Absolutely,
That is
yes.
one question. And just to go with that thing, while you are presenting the tables, in 2002 in USA, the maximum number of vehicles were produced, both passenger and commercial. And if you take the MPG in 2002, MPG was 27.5, and maybe in 2020 it will be around, I don't know, around 45 to 50. So number of vehicles has decreased, and they have become much better design wise in terms of fuel consumption. So that won't it give an effect on the these pollution from that aspect, because
Yeah,
both are comparable.
you're right. I mean, yes, they're becoming more fuel efficient. We are burning less fuel, and so therefore less greenhouse gas emission is emitted. No question about that. But more has to be done. There's no doubt more has to be done. That's the point I was trying to make. Yes, the cars have become more efficient compared to what they were in the early, let's say 2000. But more has to be done, and that's why the CAFE standard is what it is in 2025. We're not happy with 30 or 40 or miles per gallon. It has to be
Yeah, it is going
54.5.
to be 54. Yes, going to
Right.
be 54 mpg.
Yeah.
Yeah.
Right. And so again, I'll go back to what I said before. The car company makes a variety of models. Not all of the models have to meet the same 54.5 miles per gallon. It's the average of all the vehicles that they produce. And that average is calculated by a method that is given by CAFE standard. Um, so yeah, they still have to improve much more compared to what they are now. Particularly uh, if you think about what the United Nations have reported just recently, that how much temperature is rising, and it's becoming uncontrollable almost. Unless we take care of these things now, it's not going to happen soon. I mean, we are all suffering. Not only in India, I know how hot it is in Kolkata these days, or how long it remains hot in Kolkata these days. But it is here in this country also. We think of US. I don't know where you live. You live in the United States, Mr. Palit? Do you live in the
Yeah.
United States?
Yeah. Yes.
So you know how the weather is changing here. The climate is changing here.
Yeah.
The climate is how much it is changing here. So it's undeniable that we have to do something about it. To answer your questions, I think you pointed out two very good things here. One of them is parts consolidation, and that is one of the advantages of using polymers, plastics, and composites. Not so much with aluminum alloys, unless you go into castings. But if you are going to use forming, you still have to make similar number of parts and join them
Okay.
together as you do in steel.
Okay.
But with composites, you can consolidate, and therefore you are reducing not only the number of components that you have to make, you are also using less energy,
Okay.
and that's good. And the other, so you're right about that. Thank you for pointing
Okay,
that out.
thank
Yeah.
you. Thank you for your clarifications.
Sir, can I raise a question, sir?
Yes. Yes.
I will, sir. Thank you. I will raise my question. I'll just tell one thing in answer to Palit. Sir, kindly remember, Palit, that the number of vehicles in the world is expanding e to the power x. It is per vehicle, it is efficiency is going up and up. But the number of vehicles, that is something, it's a great burden. Now, my question will be, yes,
Achit,
please,
that's
please.
why I also mentioned the total number of produced vehicles went down, was maximum in 2002, and what it is today. Maybe I
No, no,
think
no.
data was given for
Please,
No,
2000.
please, please. That is the American figure.
I am talking
he's
on
the,
American figure only. I am talking on
Acha.
only
But,
American
but
figure.
but
we
he's
as a
talking about,
inhabitant, we as an inhabitant of the world, we are
No,
thinking
that's
of the
okay. That is
universal.
okay. That is okay. That
Okay,
I
okay, okay.
understand.
Thank you, thank
Okay.
you, thank you.
That's
Right. Now,
understand.
my question will be, sir. Well, yes, in electric vehicles, we produce electric somewhere and we produce not only from hydrocarbons, we can produce from solar and various other sources. And since we are doing at one point, even it is hydrocarbon, we can do carbon capture and all these things. But what about the price of lithium? In 2 years, the price of lithium has gone up 6 times. 6 times. So, what about the future of electric cars? That
so yeah.
if
So
Pankaj
I would say that lithium is a monopoly for one country. It
Mhm.
comes mostly from China, and also some from, I suppose, South America, but mostly from China. So it's monopolized, and so therefore the price is not in the hands of I mean, world market, so to speak. Yes, you're right, but uh, who knows? The future battery may not be based on lithium ions. It may be something else. I mean, lots of research is going on around the world. Um, you know, where people are looking for substitutes for lithium. Uh, but that's a very good question, though. It's not just the lithium itself, but it's the battery life. Battery life meaning that how long does it take for a battery to run down and be recharged? People here drive, miles and miles during the holidays. And would they be able to charge their batteries, uh, car batteries, to drive their cars? That's a you know we don't have the facilities. We have lots of gasoline stations or petroleum stations, but not many stations for charging electric vehicles. And so the Biden government now is putting, I don't remember the number, a large amount of money for infrastructure building, where there'll be more of these battery charging stations around the country. Same has to be done in India as well as other places where, and this is why they're wondering how Tata can sell 50,000 electric vehicles. Where are they going to be charged? How are they going to be charged? Probably there for only city driving, where people will drive a small amount of mileage and then come back home. Yeah, it's a big problem. I
the
agree.
honest answer to Tata's problem is it is mostly city based, and the cars they're selling is 150 kilometers with the batteries
Right,
that
right,
there,
right, right.
and it is limited to cities
Yeah,
and
yeah,
they're self charging. That is point
yeah,
is charger itself is within the car, and you just put it to a plug point. That's all.
yeah, yeah,
You
yeah,
don't have to
yeah,
care. That's a plus point. That's a plus
yeah,
point.
yeah.
But one more thing, I have a yeah. Come on, one more minute, please give it to me. Since I am 61 batch, I can call Pankaj Mallick, Professor Mallick as
Right?
Pankaj. Well, Pankaj, I have got one criticism for you. You see, today we people in India are sort of mentally prepared to understand in these liters and kilometers
I know,
and all these
I know.
units. And you are very kind to put all in US units. That's somewhat very difficult for us to conceive.
I can give you the conversion.
No, no, it's okay, okay. I know the conversion, but I am just criticizing you as is. That's all.
Yeah,
Thank
I
you.
know.
Thank you
I
anyway. It was
know.
very informative. It was very
I know.
informative. Thank you. Thank you.
I think instead of looking at the absolute numbers, look at the relative numbers. I think that probably, when you say cafe numbers, which was in 1978, there was some 17.5 or whatever the number is, and it's going to be 54.5. So look at the relative values
But
of
the
how.
cafe target, cafe MPG target that you mentioned for 2025, I was just checking. They are mentioning some 49 MPG
Well, there
for
are still negotiations going on.
2026. What I
Yeah,
understand, they had some standards for 2021, and that they are now revising. They are going back. Uh, so they have downgraded it from 56 to 49. Perhaps
well,
looking at it as unachievability. I mean,
yes,
can you really
yes.
achieve?
Well, that's a question that we need to wait till
If you look at
2025
the
to
targets,
see.
it's basically asking for 8 to 10% jump every year, year on
Yeah.
year. For the
So
first 2 years, they are saying it's about a 8% jump, and then it's 10%. So, and that is
yeah.
basically on your fuel economy. And now think of the other to get that to that fuel economy. What I mean, to what extent you need to reduce your weight, or to what extent you need to improve your efficiency, and that's really, I mean, difficult to achieve. Perhaps this is
Yeah,
another way of promoting hydrogen infrastructure, or maybe battery vehicles, hybrid vehicles.
well, I think there are two issues here. One is that the government is pushing the car companies to do this. Without the push, in my opinion, that's not going to
Hmm.
happen. That is not going to happen. So yes, when time comes to meet the standard, if the car companies cannot meet them, there will be negotiations and there will be changes. But unless there is a standard put up there,
Hmm.
it's a human trend. Unless you are forced to do certain things. Man, I'm making profit, so what do I care about? How much greenhouse
Health of
gas?
the
but
world. Health of the
but
world.
but
Yeah,
apparently impossible targets.
yeah, it is.
I
It
mean,
is.
if you look at it, standing on 2022, and if you are looking at 2026 targets, it's close to 30% reduction.
But don't forget, it's not the vehicles are not going to be all gasoline powered vehicles. There will be a substantial number of electric vehicles that will come in there.
I mean, that's what I'm
So
saying. It's perhaps to promote them only.
yeah, so GM has announced, the General Motors have
Mm,
announced
mm.
just not too long ago that they're going out of the you know the gasoline powered vehicles in, I don't remember what the year is, 2035 or
Yes,
something like that.
yes.
They will not produce any more of those vehicles. So
Yeah.
yeah, the industry is keen on doing some of these things, but whether it's achievable, I agree with you. We don't know that yet.
Mm.
We don't know that yet. But unless
Yeah.
there are some, um,
It's pressure
compulsion,
tactics.
I
yeah.
I have some quick comment and questions. Actually, more in the comment line. Uh, okay, I'm 68 batch, so you're all dadas. And I follow through Achyuta's comment. We should really look at the planet level rather than US level. I am in the USA based for the last 40 plus years. So I'm seeing the insane growth of vehicles all over the place. Now, India is just jumping into the situation. They're trying to build some infrastructure and getting more and more vehicles. I'm looking at a bigger picture rather than trying to focus on fossil fuel powered cars. I think the best way we in India have done using in terms of public transportation, taking advantage of railways. That's a wonderful thing. US does not do it. Okay. The China is taking advantage of it after figuring out that they have the monopoly on lithium and electric vehicle catching up. They're jumping into that bandwagon. My suggestion for India will be really, you should really, as academia, intelligence, you should really seriously think if we have to really build the infrastructure, whether for road, gasoline, sources, etc., etc., we can do exactly the same thing for electric vehicle. If we have to build this infrastructure, why not for electric vehicle and rather than fossil fuel? This is what I heard from my professor long time back when I was doing my MTech in Kanpur. He said, Kamal, don't follow the Western thought process. Watch of them, then leapfrog. I think that we are lucky that way. We never had to build so many power lines for the telephone. We skipped that and we jumped into mobile. We save billions of dollars. Same thing we can do with the electric vehicle. Rather than trying to keep building fossil fuel vehicles, if we can jump into electric vehicle, then we can save the earth and save a lot of money in terms of infrastructure that will the US will have to, and Western countries will have to go to switch from all the gasoline stores to charging stores. India can do that and save billions of dollars. So my suggestion is that for Indian academia to look into more closely with the structure, very structure is the same. And if I'm looking at your data, you are saying that 82% of the transportation vehicle they pollutes that different types of losses come into play. And if you look at the big picture, even all sources of things, almost half of the things come from mostly vehicles. So we can, as an India as a country, as a wishing superpower, I think they should really look into closely into it and see what should we do. What should we do really do? Should we really spend more money on making more vehicle fossil fuel, or really we should jump into electric vehicle? As
Kamal,
we did,
Indian government has announced that after 35 there will be no more hydrocarbon vehicles in India. They will not be permitted to be produced. That is a government statement, I think. Please.
that's wonderful. Then we should really focus on building that kind of vehicle, what we should do, and focus on, as Pankaj rightly said, lithium is monopolized by China. Okay, so they can triple, quadruple the price anytime they want. But what we need to do, actually, I'm looking into at one of the
Afghanistan has got 30% of lithium of the world. Afghanistan. China has purchased one mountain in Chile or someplace in South America which contains the lithium. They have just purchased the whole hill,
but
whole mountain.
you are right, Achyuta. But here's the trick, as my professor said. We don't have to, lithium iron is not an only battery source. There
Yes.
could be other sources.
Yes.
That is where we should focus on. And then we don't have to depend on it. Bottom
That's the
line is
research
that,
area. That's the new research area.
exactly, that is what we're talking
It's
about.
the
And actually,
most
I'm looking
essential
at it.
research area.
Actually, I'm looking at one of the commercial applications. I'm just judging it whether how good it is. That it is possible they can go out of lithium. So we can do the same thing. So basically, my bottom line summary is that as India, we should keep focusing on building infrastructure for the railroad as public transportation, and in terms of personal vehicle, let's focus on electric vehicle. Then we can basically short circuit what we the Western countries going through the pain. That's just my comment.
Thank you.
And if you have a question, then I can ask only one thing for Pankaj, is that I do not know. I'm sure the cause is cost, but titanium and titanium alloy could be another option. Because if you look from specific strengths, specific modulus, that is a lot better choice.
Yeah,
But cost, like
yeah.
I said.
I had a Department of Energy project looking into aluminum for engine applications. Yes, titanium can save a lot of weight, but the cost is too
Prohibitive.
too expensive.
Prohibitive
Very
cost.
prohibitive. Very
Yeah,
prohibitive.
yeah, we have to look into that. That's exactly. But in
Kamal,
any case,
all our dental things are from titanium, and they cost millions. You know,
And,
you remove
and
one tooth,
for automotive application, it is going to be prohibitive, at least for the short term.
Right.
and
Not only short term, I think in the long term,
the
it's
technology that we have today.
I'm not sure so. You know why? You think of CFRP, carbon fiber reinforced plastics. Okay, when we started it, I'm talking about 1980s. It was only for fancy sports like golf. It was so expensive. Now it is in the car. Is
No,
it
it's
really
not a
or
car,
debate
but
or
it's
we
not
cannot say.
it's not
But
it's really not.
before I forget it, it was a wonderful presentation, and it is really thank you, Pankaj.
Very, very wonderful
Yeah,
presentation.
30 years of
Wonderful
research.
presentation.
Yeah, 30 years of research in 30 minutes. Man, I couldn't do it. Thank you.
Thank you so much.
Great. Thank you.
And on behalf
Thank
of the
you.
department and also on behalf of the Centenary Celebration Committee, I must thank Professor Mallick for giving this wonderful lecture in this
Thank you.
forum. I mean, I mean, we got you in this forum. That's really
I
nice.
appreciate it. I appreciate it very much. Thank you for inviting me, and all the best to all of you.
Let me also thank
Hopefully,
to yes,
hopefully I will or we will see each other again sometime.
yeah, we should. Please let us know when you do come here.
Okay.
Let me also take this opportunity to thank our today's chair, Professor Vishwanath Dolui, for sparing his time and nicely leading the session. Yeah, it was a long session for us. Are we ready to close the session? Yes. On last responsibility from this Centenary Celebration Committee, we have this certificate appreciation for our speaker.
Thank you.
Professor Mallick, we have this, the digital copy will be mailing you, and we also have a hard copy that we try to hand you over or to any of your local contacts if you have any. That will be easier for us to hand over this one along with a memento that we will be handing over.
Yeah. I'll probably travel to Kolkata in 2023, and I'll contact you before that, and maybe I'll come and visit you at that time.
That's fine.
Okay.
That's fine. In the meantime, if you want us to deliver to any of your local contacts, just do let us know, or else we'll be holding it.
I don't think you need to take trouble to do that.
Okay.
They are in Kolkata, but it's okay.
Yes, we'll keep it with us.
I'll not see them anyway for another year, so it doesn't matter if you deliver it now or when I come there and see you and get it from
that's fine. We'll do that.
Okay. All right. So, thank you. Appreciate it.
So thank you very much.
Okay.
Thank you all.
Yeah. Thank you. Thanks everybody.
Night.
So good night.
Thank you everyone for joining.
Good night.
Yeah, that's right. It is what, 10 o'clock? No, it's 9 o'clock now there.
Here it's